On the previous lesson, we learned about the torque transmitted by hollow circular shaft. Today, at first, I will discuss polar moment of inertia. Polar moment of inertia of a circular section. Here, circular section means the shaft is a circular section. So, polar moment of inertia of this circular section about an axis passing through its CG, that means intersection of XX and YY axis and perpendicular to the plane. That means here this is ZZ axis is called polar moment of inertia. From the chapter moment of inertia, from perpendicular axis theorem, we know that I suffix ZZ, that means moment of inertia about ZZ axis, equal to summation of I suffix XX plus I suffix YY. Putting the value of Ixx, this is pi by 64 d to the power 4 plus here this is the same value pi by 64 d to the power 4. So this is pi by 32 d to the power 4. This is the value of polar moment of inertia and it can be written as I suffix P, I suffix J. Okay. So the value of solid circular shaft polar moment of inertia equal to pi by 32 d to the power 4, and for hollow circular shaft this is pi by 32 capital d to the power 4 minus small d to the power 4. Okay, this is polar moment of inertia. Okay, next, torsional section modulus or polar section modulus. Okay, from the chapter bending stress, we know that section modulus, that is Z equal to moment of inertia of the beam section and the distance between neutral axis and maximum outer fiber, that is Y max. Yeah, this is section modulus. But here this is circular section, so it is polar section modulus or torsional section modulus. This is Z suffix P. Here moment of inertia will be converted as polar moment of inertia and Y max, that means from neutral axis to the maximum outer fiber. Yeah, so this is radius. So here this is radius. Now J for pi by 32 d to the power 4, R means d by 2, that means here pi by 16 dq. Yeah, this is for solid circular shaft, and for hollow circular shaft this is pi by 16 capital D to the power 4 minus small d to the power 4 by capital D. So this is torsional section modulus. Okay. Now we will learn power transmitted by the shaft. Yeah. We know that power equal to work done by time. Okay, so at first we have to calculate work done. We know that work done equal to force into displacement, but here for circular section force means here torque transmitted. Yeah, torque transmitted, and displacement means here angular displacement. angular displacement. Torque means T, angular displacement means theta. For 1 RPM, 1 revolution, angle at the center, this is 2 pi. And for n rotation, this is 2 pi n. Okay, that means here theta for 2 pi n. And this is joule per minute. Okay, n for RPM, revolution per minute, and 2 pi nt minute can be written in second by 60, that is joule per second. Okay, and when work is done per second, it will be power transmitted by the shaft. So power transmitted P equal to 2 pi nt by 60 joule per second means here watt. That means T 2 pi n by 60, that means omega. Okay, that means power transmitted by the shaft, this is P equal to 2 pi nt by 60 or T omega. This is okay. On the next class, I will discuss different numerical problems on this torsion. Okay, thank you.